Hello, Google. How are you? I hope you're doing well. I wanted to ask, how old is the universe? 13.7 billion years. Okay, let's see what Wikipedia says. 13.7 billion years. NASA? 13 billion years as well? How did they come up with that number? And why is it the same? Simply two methods were used to estimate this number, one good and the other not that great. The good method. During the past century, with the technical development of telescopes, we noticed strange things. The colours of starlight from distant galaxies shift toward red, and this, in fact, should not happen. Why? To understand the reason, we need a quick lesson in the chemistry of elements. Any chemical element, if it gains or loses energy, starts emitting light in certain colours. Imagine the element as a lamp. Once you provide it with energy, it starts releasing it in the form of heat and light. These colours come from iron. These colours come from oxygen. And these come from your screen every Sunday. From our experience in studying the sun and nearby stars, we know that stars are mainly made of the gases helium and hydrogen. Here is the problem. Hydrogen and helium are wonderful gases, but they cannot emit the shades of red that we see. Hydrogen can emit some red, but it is different from the red that stars produce. Sorry, hydrogen, it's okay, buddy. So if the distant stars are made of hydrogen and helium, why does a different colour appear? Are they made of other materials? Possible, but unlikely. The best explanation is that the colour change is caused by the motion of the stars. Listen, there are certain phenomena that happen to light called redshift and blue shift. If there is a light source moving toward you, its colour shifts toward blue, and if it moves away from you, it shifts toward red. This happens because the wavelength of light is compressed or stretched with motion. When the wavelength is compressed, the light turns blue, and when it is stretched, it turns red. The red colour then indicates that the stars are moving away from us quickly. The star sends its light normally, but because of its motion, the wavelength of light is stretched, so it shifts to red, and we see it red. The strange thing is that most, if not all, distant stars and galaxies show this behaviour. All of them want to move away. Think a little. If all these stars are moving away from us, this means that in the past they were closer to us. And if we trace their path, we will find that everything returns to one single point. Physicists call this point a singularity. It is believed that everything in the visible universe, galaxies, stars and planets was once gathered in one single point. And the theory says that everything came out of this point in an event called the Big Bang. And since then, the universe has been in a state of constant expansion. Now, after all this, let's gather the information. 1. The universe started from a very small point. 2. The universe is in constant expansion. 3. We can calculate the rate of expansion of the universe by measuring the speed of stars moving away from us. We put this data into one mathematical equation and boom, we get the age of the universe, 13.7 billion years. Everything you heard was the first method, the good method. But there is another method, less accurate, but it supports the previous calculations, so we accept it. The less accurate method. Since the beginning of time, people raise their eyes to the sky watching the stars. And sometimes they imagine them as goats, mermaids. Let's just say they didn't have the internet at that time. They had the stars to entertain their free time. Anyway, the stars have been studied since forever, so we know their entire life cycle, from their birth until their death. And to estimate the age of the universe, we started looking for the oldest celestial objects. The idea, if we find a star of age, X, then the universe is definitely older than X. We directed telescopes to the oldest stars we know, and we started determining their ages. How old do you think the oldest star we found was? 13.2 billion years. Very close to the number we got from the first method, right? We found many stars with ages around 12 billion years, but we never found a star of 14 billion years. So the results of the two methods are consistent and close. Notice that knowing the age of the oldest star alone is not enough to determine the age of the universe, because maybe tomorrow we will find an older star and ruin all the calculations. But since we have two different methods with similar results, this confirms that our calculations are accurate, and the age of the universe is 13.7 billion years. Quick summary. So, how did we know the age of the universe? 1. We discovered that stars are moving away from us. 2. We calculated the time needed for them to reach their current positions. 3. We calculated the ages of the stars. And we found that the two results are close. Congratulations, now we know the age of the universe. Goodbye. Wait, before you go, I have a small favor to ask. If you enjoyed my content, I invite you to subscribe to the channel. I'd really appreciate it. See you in the next video.